Greetings, calculus students. As promised, a little homework help for you. Part 1, there may be more. These are ones that people have asked me about. If you have other ones on homework 1, let me know. I want to talk briefly about factorials. So like, if I have 5 factorial, I know everybody should know that means I'm going to take a new pen here. Sorry, getting used to my S Pen still. So that means I'm going to take 5 times 4 times 3 times 2 times 1, and then 3 factorial on the bottom is 3 times 2 times 1, and from there, I know the 3's, the 2's, the 1's are all toast. I get 5 times 4, which is 20. Now, that works when it's nice and small, like 5 factorial and 3 factorial. If I had like 25 factorial over 22 factorial, the last thing I want to do is to write all that out. So I guess a better way I can think of to do it is this. I want you to get good at how I can reduce these down. So basically, I know on the bottom, that's my smaller one, 3 factorial, which means 3, 2, 1, and so forth all the way down. So I'm going to start on top. 5 factorial means 5, and then 4, and then I know it means 3, 2, 1. Really, 3, 2, 1 is just 3 factorial. So basically, 5 factorial means I have 5 times 4 times 3 factorial, or 3 on down. Those cancel, and I'm left with 20. So like if, for instance, I did have something like, let me pick this color. Let's say I did have something like 36 factorial over like 34 factorial. There is no way in this world I am going to take the time to do this nonsense. It's just not going to happen. I would simply take the bottom one, which is the smallest one, and leave it alone, and understand that the top is 36 times 35 times 34 on down, and then that would give me 36 times 35, whatever that happens to be. I'm just not that curious, but you guys could do the math on that. Do you see the idea? That being said, let's try number 1. N plus 2 factorial over n factorial. First, I identify which of the two is bigger. Well, n plus 2 is bigger than n. So I'm just going to leave the bottom as n factorial, which means n all the way down. N plus 2 factorial means n plus 2 times n plus 1. And again, I just keep going down by 1. Well, that would leave me with my next term being n and n minus 1 and n minus 2, which really is just n factorial. So it's n plus 2 times n plus 1 times n and everything after. Those cancel, and I just get n plus 2 times n plus 1. If you wish to FOIL that out, it's not that hard to distribute. I'm just going to leave it like that. Part B, same deal. First thing I see is I'm multiplying by 3 in both cases. They're toast. Next thing I see is that I have an n factorial and an n minus 4 factorial. Leave the smaller one, and then take the bottom one, which is actually bigger. N is bigger than n minus 4, so that would be n, and then I go down by 1. That would be n minus 1, and I just keep reducing by 1 until I match up with the smaller one here on top. So it's n, n minus 1, n minus 2, n minus 3, and then, well, n minus 4 and beyond. Those cancel. I get 1 over n minus 1, n minus 2, n minus 3. Again, if you feel the need to FOIL that out, you do you. I'm not going to ride that train. You know, if you do feel like you want to do that, society must step in before you do harm to yourself. It's not, no, it's just not necessary. Just let it be. 6 was asked about whether it converges, diverges. How do I know? You say, well, is this nth term test? Is this geometric series test? I don't know. Well, for me, it's kind of simple. I like the nth term test because it's something I can usually do pretty quickly in my head. It's kind of my go-to. If this doesn't work, then maybe I try something else. So our nth term test says I'm going to take the limit as n approaches infinity of n squared over ln of n. Well, if I do that, that's going to give me basically infinity squared over ln of infinity, which you say, well, what is that? Well, ln is a graph that looks something like this. It keeps getting bigger, so this would be infinity over infinity form, or we called that, when we were talking about L'Hopital's rule and such, we called that indeterminate form. Which means I don't know what the answer is, but I can factor, I can synthetically divide, I can use L'Hopital's rule to try it again. Now again, L'Hopital's rule just means take the limit and then derive the top, derive the bottom. The derivative of n squared on top is 2n. Derivative of ln of n is 1 over n. And then you copy, change, and flip. And that'll be 2n times n over 1, which is limit infinity 2n squared. Now, what happens when you plug infinity here? Well, 2 times infinity squared is ridiculously huge. It approaches infinity. More important than what it does equal is what it doesn't equal. 2 times infinity squared does not equal 0. You say, well, why am I concerned whether or not it equals 0 or not? Well, because nth term test says that if the limit as n approaches infinity of your series, what would be n squared over ln of n, if that's not equal to 0, then the series diverges. So there we go. Let's try the next one that I was asked, number 12. Okay? Number 12, this one to me just jumps out as being a geometric series. If you say, okay, how do I know it's a geometric series? Here's how I know it's a geometric series. I see something to the power n. I see something to the power n plus 1. For me, I can tell you right now that this is a geometric series. And since both the e and the pi both get raised to like an n or an n plus 1 or an n plus 2 or an n plus 5 power, whatever the case may be, since they get raised to like an n something power, I can even tell you that the ratio is whatever gets raised to those powers. So I can tell you the ratio is e over pi. Now, for those of you that can't tell that, let me show you how you can. If you're not familiar with like doing that, let's just do this. Let's start and just find a couple of terms. So we're starting with n equals 0. So my first term would be e to the 0 over pi to the 0 plus 1. E to the 0 is 1 over pi. My second term, I started at n equals 0. Now I go to n equals to 1. So that would give me e to the 1 over pi to the 1 plus 1, which would give me e over pi squared. If I plug in the 2, that'd give me e squared over pi to the 2 plus 1, which would give me e squared over pi cubed. And I can keep doing this, but my next term, I can just tell you just intuitively, would be e to the 3rd over pi to the 4th. So then if I examine this, what I see is to get from each term to each term, I basically multiply by 1 on the top and by a pi on the bottom. I'm sorry, I multiply by e on the top, excuse me. 1 times e makes e. E times e makes e squared, and then another pi times e over pi. That's my ratio. So you can either go old school and just crank out a few terms and try to figure out your common ratio that way, or, like I said, if it's being raised to like an n or an n plus 1 power, that's going to be part of your ratio. So let's finish this. To determine whether it converges or diverges, I take the absolute value of the ratio and I want to compare it to 1. If it's bigger than 1 or equal to 1, the series diverges. If it's less than 1, it converges. Now, easy way for me to think of it is this. Pi is a number, an irrational number, a little bit bigger than 3. E is an irrational number a little bit less than 3. It's like 2.7182, all that jazz. So pi is bigger than e. So I know that, since the bottom is bigger than top, I know that's less than 1. So since my absolute value of my ratio is less than 1, then the series converges. Now the cool part with a geometric series, let me erase to have a little room here. That's not what I wanted to do. Let me try that again. Let me erase all of this junk. I can not only tell you that it does converge, it is one of the few series I can tell you what it converges to. And we have a formula that says if it does converge, that it converges to a over 1 minus r. Well, a is what I would get if I plugged in the first term 0. And we already did that. That'd be e to the 0, which would be 1 over pi to the 0 plus 1, which would be pi. And then I divide it by 1 minus the ratio e over pi. Now comes a little bit of intense algebra here. First thing I'm going to do is to make this bottom have a common denominator. So that's going to give me, let me see, I'd have to multiply that by pi over pi. So that'd give me pi minus e over pi. Copy, change, and flip. That's 1 over pi times pi over pi minus e. They're toast. So I can tell you that this, not only does it converge, but it converges to 1 over pi minus e, which is a pretty small number, but that's what it converges to. Okay, last question I want to go over, or that was asked, was number 20. And it basically asks me, here's a series from 1 to infinity, n squared plus 2 over n cubed. And first thing I'm asked to do is to find the limit as n approaches infinity of this. When it says an, that's your an. It's the part that's being added that you're plugging into. Now, first thing I know is that when I talk about squaring infinity, plus 2 is insignificant. So that basically gives me the limit as n approaches infinity of n squared over n cubed, which reduces, if I divide both top and bottom by n squared, 1 over n, and 1 divided by n as n approaches infinity, or 1 over infinity, approaches 0. So, the question for part B is, why can't the nth term test be used to determine convergence there. First of all, because the nth term test is called the nth term test for divergence. It only does divergence. It cannot tell you if something converges. So the idea here is this. It will diverge. See, like if I have a series and I keep on like adding numbers and stuff like that, and these numbers are not zero, that just means my series is just getting bigger and bigger and bigger, which means it diverges. Now, so some people would argue then, well, since I am basically, if I go out to like the billionth term, I'm eventually adding zero, that means it converges. No, that's not what the nth term test says. It says if the nth term at the limit at infinity is not zero, it diverges. If it is zero, I don't have a clue. So basically, I can tell you why can't the nth term test be used? Because nth term test is inconclusive when the limit as n approaches zero of whatever series equals zero. A good way to think of it is something like this. If there's a kid in class that never shows up, blows off Cal BC, never attends the lessons, doesn't bother to ask questions, whatever like that, what do you suppose the chances are that they're going to get a 5 on the exam? Not very good. So if somebody ditches a lot, they're not going to get a 5. So does that mean that if somebody attends class that they're guaranteed to get a 5? No, it doesn't. So that's kind of the analogy here. Just because the limit equals 0 doesn't guarantee that it's going to converge. It might not. Just like the kid who does attend class every day, they may get a 5, they may not. There's more testing or more stuff involved in that. Either way, I hope this helped a little bit. And if you need other ones asked, let me know. I can put together a part 2. Thanks, guys. Bye.